The usual problem that we solve under the compound amount formula is finding the present value and the future value of any loan or any investment. In this video, I'm going to show you how to derive the formula for I, which is the interest rate per compounding period, and N, which is the number of compounding periods. And also, we're going to solve some problems relating to these two other parts of the compound amount formula. So for instance, given this problem, if 40,000 accumulates to 100,000 in 10 years, find the nominal rate if the interest rate is compounded quarterly. So in this problem, the unknown is the nominal rate, which is denoted by J. And this is compounded quarterly. Therefore, M is equal to 4. Also, we are given a present value of 40,000 and the future value of this 40,000 is equivalent to 100,000 pesos. Also, we are given time, which is equivalent to 10 years. Since this is compounded quarterly, therefore, the number of compounding periods given by the formula N equals M times T, where M is 4 and T is equal to 10. Therefore, we have 40 quarters. We all know that in the compound amount formula, J is not present, but we know that J is related to I, which is part of the compound amount formula, where I is equal to the nominal rate divided by the number of compounding periods. Cross multiplying M to I, therefore J is equal to I times M, or the nominal rate is equal to the interest rate per period times the number of compounding periods in a year. Now, we're going to derive the formula for the interest rate, or the formula for I. We know that the compound amount formula is given by F is equal to P times 1 plus I raised to exponent N. So we're going to solve for I, or determine the formula of I. So first, we divide both sides by P. This will cancel out on the right side. We're going to have 1 plus I raised to N is equal to the ratio of the future value and the present value. Then we're going to extract the nth root to cancel this exponent. So nth root of the left side, also the nth root of the right hand side. This will cancel out. What is left on the left side is 1 plus I. And on the right side is nth root of F over P. And finally, we're going to transpose 1 on the other side of the equation. Therefore, I is equal to the nth root of F over P minus 1. This will be our formula in determining the interest rate per compounding period. So in the problem, so F is the future value, P is the present value, and N is equal to 40. So therefore, substituting those values, N is equal to 40. So that's the 40th root of the future value over P, that's 100,000 divided by 40,000 minus 1. Take note that this minus 1 is not part of the radical part of the formula. So this value is equal to So the value of I is equal to, taking 4 decimal places, this is 0.0232. We're going to multiply this by 100%. This is equal to 2.32%. And finally, the nominal rate is J is equal to I times M. Therefore, we're going to multiply M, or for this case, we're going to multiply M is equal to 4 as indicated in the problem, since it is compounded quarterly, to determine the value of J. So that's 2.32% times 4, which is equal to 9.28%. If you're having difficulty in determining this value using your calculator, so particularly if you're using Casio calculator, the input should be 40 shift caret sign open parenthesis 100,000 divided by 40,000 minus 1. And you should get this value. And if you're using the calculator, the standard calculator on your smartphone, which is typically cannot solve radicals or higher than an index of 2, we can use this by converting the index of 40 into a fractional exponent. The index of 40 in this radical into a fractional exponent. And this part is equivalent to an exponent of 1 over 40. So on your smartphone, you can enter 100,000 divided by 40,000 raised to the exponentiation. Usually that's y raised to x or x raised to y on your smartphone, on the calculator of your smartphone. And then the radical part, index of 40, is 1 divided by 40. And then we subtract 1. On your calculator on the smartphone will give you this value.